Well, just a quick intro. I'm Adam Foos, VP of Product Management for SD-WAN here at HPE Networking. Well,
I'm Nirmal Rajaratnam. I'm Director of Product Management.
So this is actually the first time we're showing off our combined SD-WAN portfolio. And so I want to just quickly walk through what this looks like. This is part of our overall SASE offering. And then Nirmal is going to dig into a specific piece of all this. So just starting on the left side here to show you what we had with Aruba. We have HPE Aruba Networking here. We have really, two different SD-WAN products. We have the SD-Branch / micro-branch solution. These ones are fully managed through Aruba Central, and that's where we're going to focus our time today is in Central and the application intelligence engine that we are launching. We have EdgeConnect SD-WAN, which is managed through the EdgeConnect orchestrator. This is also known by many as the Silverpeak offering. HPE acquired Silverpeak 5 years ago, which is where I came from. And then we've also added into our portfolio here the HPE Juniper networking offering with the Session Smart Router. And so this is actually manageable through two different places today, manageable through Mist and through the SSR conductor. But one of the things I really want to reinforce is that, yes, these devices all do SD-WAN, but they also do local edge firewall capabilities. So they are all next-gen firewalls. They all service chain traffic to our security offering, and they work within our greater ecosystem. And we are, of course, always working to advance those integrations together. So this is just the high level of our SD-WAN gateway portfolio. And with that, I'm going to hand it over to Nirmal here.
Okay, thanks, Adam. So as Madani talked about, we are part of the SASE and security pillar. So obviously SD-WAN is part of that. So what I'm going to be touching on is mostly on the security side of things, because obviously it's security field day. So what I'll be talking about is traditional firewall functions or traditional security functions that is on-prem or at the edge using your gateway or any of your policy enforcement points. So the most common, again, coming from a network security standpoint, the most common security challenge when a bad actor gets into the network, what is the most common problem that you run into? So, all right, I'll go with that. So to me, it's more of a lateral movement. So once a user gets in or a bad actor gets in, and if one of the devices are impacted, it's going to affect everybody because of the lateral movement. And that's why, traditionally they come up with this static segmentation or VLANs. And VLANs obviously have problems, which is, it's fixed. There is no mobility. You have to maintain on a regular basis. So then came the whole identity-based segmentation or dynamic segmentation based on user and, device-based identity. So you basically identify posture assessment and fingerprint the device based on what they're capable of doing. You admit into the network and then park them in a specific, VLAN or a particular segment. And then based on their behavior, you're going to do certain analysis. This is where what is missing here is if I simply go based on user and device identity, that's not sufficient. What we really need is, if you look at the network, typically what is mostly transacting is your application and data. So if I don't know the application posture or application identity or application, what is actually happening in my network, you're not really doing or benefiting from the dynamic segmentation. So what I'm going to be talking about is what we are introducing as application intelligence engine. So this application intelligence engine has a bunch of different functions. One, obviously, is to give you that benefit of protecting from that lateral movement by using dynamic segmentation, using the application posture and application fingerprinting aspect of it. So if you look at application in a general environment, you have multiple different sources of application providing different information. So how do you guarantee that you can identify an application correctly and reliably for all different scenarios? Because you have deep packet inspection, you're going to do profiling, you're going to do policy enforcement, you're going to do performance monitoring, you're going to do routing and steering. There's so many different things that you're going to be doing. You have to reliably use a unique way of identifying all of those use cases with the same application or same application identity all the time. So today what happens is each of those engines are going to be using their own way of doing things. So it's hard to correlate and bring them together. What the application intelligence engine brings you is a way to kind of correlate all of these different sources and bring them under one repository by correlating, collating, normalizing, and sanitizing all of these different sources into one single, repository, what we call as the application catalog. And once you do that, as part of the normalization process, because different sources or different engines, in this case, if you look at this, we have potentially multiple different sources. There's CSI, Cosmos, WebCC, and a bunch of different things. Each of them might have overlapping identity. So for instance, Cosmos as a deep packet inspection engine might tell you that this pattern, based on the first 5 or 6 or 7 packets, this looks like a Dropbox. Same thing could be done based on a URL, and they say, oh, this is going to dropbox.com, so therefore it is Dropbox. They both may be coming from 2 different sources. So I have to say that, okay, both of them are talking about the same thing. I'm going to bring them together, because there are certain cases where one engine may say that dropbox.com, another might say Dropbox Inc. So both of them are same. For humans, it's straightforward, but from a digital standpoint, it's not straightforward. So we bring them together and create them as base applications first, and then we organize them into different categories as well. So for instance, you can say Dropbox, Box, and OneDrive, and all of those are file sharing or cloud file sharing. So you group them under one thing and make it as a default application category that you can take some of these base applications, stick them under the base category, and create them as an organized set. So where does this help? I mean, before I get to the use cases, how does this get distributed? So what happens is, for each of these different sources that you have identified, you can create what we call as the vendor services. First of all, this application intelligence engine is a service that is running in the Aruba Central that Adam Foos talked about. And that service is responsible for all of these functions. So for each of the sources that I talked about earlier, it's going to create what is called as a vendor service, and it's going to ingest information from each of those vendor service that will come in, and we're going to merge them into a common repository, the way I showed you earlier, which is creating a base application using normalization and sanitization of multiple sources. Once that is done, the application intelligence engine is responsible for pushing down the signature to the right type of devices. In this case, you might have multiple policy enforcement points. It could be your access point, it could be your gateway, it could be a switch, or anything for that matter. So what this does is it tries to identify what is your capability. Based on that capability, it's going to distribute the appropriate signature set to those particular devices so that they can do the enforcement. Now, each device might have different engines that are running for different purposes. So they go through and ingest those signatures, and each of those engines will go through and inspect and do their function. Once they are done with their function and do the policy enforcement, then they upload the telemetry that comes back to Central. There we stitch them together because each engine may have only certain information, but the application intelligence engine has the full data of all the different information. So it's going to bring them together and enrich based on the telemetry that's provided with all the additional metadata and additional information it has. So that way you get a much better, much richer information that is all correlated into a common place so that they can leverage this for different use cases.
It seems like there's a lot of configuration.
No, this is all hidden behind the scene. You don't have to do anything at all. Basically what happens, so let's say, for example, you have an access point. Access point, you turn on deep packet inspection, and let's say it also has to inspect the outbound traffic that is going to, let's say youtube.com or whatever. So in this case, there are 2 different engines that are impacted. So one is, it's going to look at the traffic and do deep packet inspection of the pattern and then compare with the signature. All that it's doing is pushing down the signature, and when it goes through the pattern of packets, it's going to look at it and say, okay, this is the signature that matches, so that means this is YouTube. And then subsequently it goes on, somebody goes to the browser and opens it, and in whatever, in some cases, let's say they're not able to identify through the deep packet inspection, or if DPI is turned off, now it's going to youtube.com. Now there's another source which is going to say that, what is youtube.com? So it's going to say, oh, that is streaming, and this has this reputation, and so on and so forth. So it brings that down. Now there are 2 different engines doing 2 different things based on the same exact application. So now you bring them together and say, oh, this one identified as YouTube, this one identified as youtube.com, both are actually same because I combine them as a base application. Now I know the DPI metadata it provided, as well as the other source, other engine that it provided. I can bring them together and say, this actually means this. This is not just application, it's also streaming. It has capable of doing all of these functions. Here is the reputation, here is the compliance, and so on and so forth. So I'll give you a real world example. And this actually happened in one of the customer environment. So let's assume that you had only one of those engines. And let's say, just like right now, we are going through Zoom. One thing you'll notice is Zoom is not reliably identified by all engines exactly the same way. In our case, that's what happened. So DPI looked at it, which is a deep packet inspection using the Cosmos engine, looked at it and said, okay, I can identify Zoom in probably say 60 to 65% of the time. Okay, I got that. Remaining 35% we still have to address. So there's another engine that looks at it and says, this is going to zoom.us, therefore this is also Zoom. And that, let's say it covers another 10, 15%. Then we look at the port and protocol, which is another local, homegrown environment, homegrown identification engine that will look at ports, protocols, things of that nature and say, I'm going to create a repository, and based on this port, this protocol, this looks like Zoom. Now, if you look at this, this might cover another 5 to 8%. So if you look at all of this together, now I'm getting close to 95% of the overall identification of an application. Whereas if I only took one particular engine, I would have only covered 60% or 65%. So that's the advantage of bringing all of them together and merging it into a common repository. Did I answer your question?
Yes.
Okay.
Still seems pretty complex.
No, it's all behind the scene. That's what the system is doing. You're not doing much. I'll show you what you're configuring.
Sure,
when I
until
go to the demo.
something goes wrong. But go ahead, yeah.
Yeah, can you expand on that?
Well, troubleshooting.
Yeah, I can. I'll show you that aspect. That's why I think bringing them together is helpful, because different engines point out same application differently at different point in time. So I need to know that what this one said versus this one said is all same. So that's the whole reason we are creating that common distribution. And I'll get to the demo so you can see what is going on. So I'll start with the dashboard. I don't know how familiar you are with the Central. So Central is our management portal where you can use it for provisioning, onboarding, licensing, and all kind of management, including policy monitoring, policy definition, troubleshooting, all aspects of it. You can actually do that. And what you see here, I have an environment which has multiple sites. And I'm going to, let's say I'm going to take a role of a security person who's managing a company's network. Let's say they are into web hosting and development and things of that nature. So let's say I am that person. So I come in, and one of the first thing I'm going to do is I'm going to say, okay, let me go to my site and figure out what's going on. So I'm going to go and run a command, which is like a chat command saying that tell me the application posture of my site. So obviously this is a agentic mesh that we announced a couple of months back. What this is doing is it's spawning a multiple set of agents that's going to go through and look at my prompt that I submitted, and it's going to analyze information with the information that it knows. And it's going to spawn multiple agents. As you can see, it finished thinking, but you would have noticed that it was going through using multiple different agents to do different things, one for documentation, another for search, and so on and so forth. So it gave me a quick summary of what actually happened or what is in my environment, because the question I asked is, tell me the application posture of my site. So it understands my site and gives me that information. So here at the top level, it says your San Jose site shows healthy network with 23 active applications, predominantly trustworthy. So that's good. I don't have a problem with that. But I'm a security person who's responsible for my company network, and my company is involved in hosting and development tools. So let me go.
Was that information that you just prompted exportable?
Yes, you can export it. So if I go here, so I can select that, and yeah, you can export
the data table.
Yeah, you can export that information. So so now that I'm working for this company, what I'm going to go and do is I'm going to look at all the different application that my application catalog has gathered to see, how are my applications in my network, or what applications are available for somebody to use. So one thing I'll start off with is the application catalog that I talked about, where you take the base application, categorize them, and combine them, and curate them, and create a category. So it's giving me the list of category and tells me what are all the application in each of the categories. So for example, if I click on this, it's going to show me the list of applications. And as an administrator, I can say, I don't want some of these applications to belong to social network. I want it to belong to something else. I can actually uncheck this and mark it into something else. But in my case, I don't have access to make those changes because based on the role that I'm provided, I'm not allowed to make changes to these applications because I'm a security person not dealing with application catalog itself. So it gives me the insight into that. So it's giving me the category. Now, if I go to application, this is where you'll see some interesting information. So for instance, I talked about multiple sources of information coming together. So if you look at this, one, it's telling me Dropbox, it's giving me the history of the company itself, who it belongs to. It tells me all the different domains that this Dropbox application is potentially going to be using. And it's also going to give me a security score with information of how did I come up with its score. So it tells me this is a trustworthy application of score of 94. And it gives me, based on these, what you see, these different bars, or these are based on the different domains. It's giving you a score for each of the domain. So some of them, or most of the domains, are in a trustworthy state, but some of them have low risk, some of them moderate, and so on and so forth. It also gives you another set of information, which is what are the potential vulnerabilities in this application. It's giving me a list of vulnerabilities, so I can go and right-click and look at the vulnerabilities itself to see what are those vulnerabilities. So it gives me some high-level information. So here it says application clear text credential exposure in memory vulnerability. That's one of the things, one of the vulnerabilities talking about. In addition, it also tells me about the encryption protocol, what type of protocol it's using, what is my access control, if they have MFA enabled or not, what other certifications are there. So if you look at this, there are two different sources that are giving me this information, and they are also different time bound. The top portion is actually over a period of time. It's an aggregate of everything that's happening until now. And this one is more real time, in the sense related to this. It may be in the last 1 day or 1 week or so on and so forth, which tells you that here are the details based on what I know last from the recent time. So basically, these are two different sources that are bringing together. As a security administrator, now I get a much better sense of what these applications are capable of, or what kind of security it applies. Now, because I'm a security person for an IT hosting company, a web hosting company, what I'm going to do is I'm going to look for applications that are necessarily relevant to me. So I'm going to go look at IT services and hosting, sales and CRM. I'm going to look at development tools, cloud sharing, and so on and so forth. So let's say I picked a few applications, and because I'm looking at security, and today, as of right now, what I ran, it says it's in a pretty decent form. It's in a trustworthy state. I don't want to mess up that, so I'm going to look for any of these kind of risky applications. So let's go ahead and do a search on that, and it gives me. Let me sort by risk score. So it says that there is at least one application that is high risk, and there are some suspicious and moderate. So if I go in, it's going to tell me why it is. So here it's 100% of them are all bad. So in this case, there's only one domain, and that whole thing is really bad. There's no MFA. The encrypted access it's not encrypted. There's no authentication. It's pretty bad. So, and if I look at this, there's many of them in that state. So most of them, actually more than 44 applications, are in a state of pretty bad state. So I don't want to mess up my network, which is in a pretty decent state. So what I'm going to go ahead and do is kind of preemptively, I'm going to say, I'm going to set a policy such that, I'm not going to allow my users to use this application while they are on my network. So if you notice, all of these are done at a global level. Basically, what it does is all these policies as an administrator, I'm defining at a global level. I don't know who's going to be the enforcement point. I don't know which device is going to get what signatures. I don't know any of that stuff. I'm doing everything at a global level. So I go in and I select a role-based. So as I mentioned earlier, we can use identity-based profiling to admit users into the network, and then you use the application posture to figure out dynamic segmentation. So here, what it gives me is the list of different policies that I have defined based on who I'm assigning it to. So in my case, I'm going to be doing this for my employees. I'm going to set a policy here. So I noticed that any allow, which is not a great idea. So I noticed that there are many applications that are not in a good state. So I'm going to go ahead and add a rule about this to deny applications that are not supposed to be there. So how I'm going to do that is I'm going to select based on a role. Role is basically, if you're familiar with the Aruba approach, it is a combination of fingerprinting a user and device and posture assessing and getting that information and creating a tag for that. So that's what it does. So I'm going to say, I'm going to choose certain roles that I'm going to apply this. So because I am HPE, I'm going to look at all the different ones. Let's say here I've identified a role for camera, so I'm going to block that as well. I'm going to select contractors, engineering organization, marketing, because they maybe use Salesforce and CRM tools, and we saw that they were actually moderate risk. And I'm also going to block product management. I'm also going to block the sales folks. I'm going to allow the support and security folks to deal with it. It's okay. So now I selected those roles, and I'm going to assign it to any destination. And what you'll notice here is there is a new category that we have created, or new destination, which is based on this combined repository or the tag, that application engine that is doing. So I'm going to choose this, and I'm going to go based on application category and say, I noticed that most of the IT services and hosting had pretty bad. The first one we saw was high risk. There was a suspicious one. So I'm going to select that category, which has a bunch of different applications under that category. So I've selected these 6 different roles, and I said, if it belongs to this category, now I'm going to block it or deny it. And I only care about when they're in my network. So I'm going to define a time range. So I've already defined business hours. So I'm going to choose that as my time when I'm going to enforce this policy and create the policy. So once this policy is created, you'll notice that it'll get added here because I said above. Now the policy is done and it is created. And now 2 things that get pushed down to the device. One is the application signature from that repository that you saw, and these policies that I have defined. What happens is there's a bunch of things that happen behind the scene, which is it'll look at the capability of the device, the scope of the device, and topology where the device belongs. Based on that, it's going to push these policies based on the scope it belongs to, because if you see here, I have multiple different scope. I can do it at global, site collection, site, so on and so forth. And based on the device it belongs to and where these policies are supposed to go, it'll push those policies. In addition, it's also going to push these signatures that we saw before from this application itself. So once that gets pushed down, you'll notice that those signatures are going to get enforced. So I'm going to go to the command line and show you quickly how that information went into. So because I'm particular about my site, which is the San Jose site, I'm going to go to the command line console, remote console of the gateway right from here. And I'm going to choose, in this case, I have 3 gateways. I'm going to choose this gateway because I know that's where the traffic is set up. So I'm going to log in using my credentials. And I'm going to look for the session information. So show data path. And because I'm looking for specific type of things, in this case, because it's a gateway, I know that they can receive all the different signatures. So I'm going to look for specific ones. In this case, as you saw in the presentation, I had different tagging for each of them. So I'm going to choose a specific one. In this case, it's called C, which is designating to cloud security intelligence as an engine that I want. And in addition to that, I also want to know all the base applications. So what you see here is telling me all the data path or the transaction that's happening based on what has been delivered here. And you'll notice that some of the tags are identified here. So in this case, Aruba Networks is a website. It has the tag that is classified by CSI with a tag of this one, and there's a transaction of that type. And there is, in this case, since I only look for C, it's going to show me all the ones that are classified by this particular engine and it's matching that particular signature. So that's what it's actually doing. But this applies to the whole data path. As it goes through the data path, different engines might use different aspects of it, but it's showing you that part of it. So this will give you a quick high level of what is going on. But this is not enough. You want to know what happened overall from the the complete set of things. So I can go to the applications and see all the different applications that has been going through, and it gives me a high level information about those applications, who are using it, when did they use it, all that information about it. In addition, it's also going to give me some performance information, all that. But main thing to point out is now I have a unified view of all the application independent of the use cases that I can use for security as well as for performance aspect of it. So that's one part of it. And from a use case standpoint, the same classification can also be used for fingerprinting, as I mentioned before. So if I go up, it's going to tell me some information about security, and notice that it's giving me some insights that these are all based on the application pattern or usage pattern. That's how it's giving me. For example, it's telling me that there's an abnormal data upload, or there's a suspicious protocol that's happening. And this is because I'm able to see the pattern of the traffic and then recognize that this device, although it was onboarded, based on the pattern, I know the behavior. Based on that, I can figure out what type of device as a dynamic prioritization, dynamic profiling standpoint, because when it comes to profiling, you're not just going based on static information. You can use dynamic information. And in this particular case, because we are talking about dynamic segmentation, I can also use the pattern of the application usage and get information to figure out how should I treat this device. So that kind of gives the overall on the demo part. So from the simplicity aspect of it, everything I'm doing is at a global level. I don't know how it gets implemented, how it gets pushed down, how it gets enforced. As a global security administrator or site administrator, I only care about pushing the right set of policies to keep my network sane and without any problems, how it was when we started. So other than that, the application administrator can go and do their side of things. So for instance, in this example, it shows that I have business application that I create as a custom category. I put in certain application that I feel is right for my business users, and they go and do this stuff. But I, as a security administrator, I don't have to worry about that. All I care is setting the right policies and pushing down the right policies. So there is distribution of labor. There is no overlap. I don't have to worry about them. And it's completely dynamic, taking all of that into account.
I have a question on discovery of shadow IT. Just broadly, I suppose, understanding how is the IT team take comfort in that any new applications fall under this?
So unknown applications.
Unknown applications.
Yeah, so we do have, you can actually look at unknown application, but because we are looking at, as you saw, there's like 5-6 different categories or engines that are providing these different sources. And since we can bring all of them together, we can cover quite a bit of applications, if any application is out there at all. Because a lot of these are almost live updates, where anytime I get new applications, I'm going to push it down. So it's very rare that you're not going to know, but it is common that I can still mark it as unknown or not evaluated. We will see those applications. You'll see the traffic pattern. It'll be marked as unknown or not evaluated. So just like how I did right now, if I know that this is unknown or suspicious or not evaluated, I might put it only to pilot users and not allow it for everybody else. So by default, I can deny for everyone and only make it available to certain folks until it is made available. On top of it, because I know, even if it is unknowingly being allowed, I know based on the telemetry and information that somebody has used this application and how are they using it. And since I can do a chat and figure out how many are using unknown applications, I can still get that info.
Just for clarity, all this was done in Central.
Yes.
So this is relevant. We saw those 3 different SD-WAN or connectivity solutions. This is relevant only for that first one, correct? The software-defined branch.
The application intelligence engine can be used across because it's a service.
Sure.
As of right now, it is on Central. It's running as a service on Central.
Okay.
So there is intent in bringing all of them together or using that engine for multiple different sources. Like you saw, EdgeConnect, for instance, which is right now a separate orchestrator. you can use the same engine for that as well.
But that's a future state. That's where
Yes,
you want
that's not
to
in
go.
the current. Yes,
Okay,
not
that's what I want
current.
to make sure that we just
Yeah, not current.
understood what is relevant today versus
Today, that is
yeah.
correct. It is only in Central. That is correct.
Thanks.
Thank you, Nirmal.
Thank you.
And thank you, delegates here in the room, delegates that were remote, and those of you that are watching the live stream. As I sort of led the opening of the session, there's a lot of really cool security technology now bringing these two great companies together. We just only had enough time to kind of cover 2 areas. We almost said, let's do for 3, but we kind of knew a lot of the technical questions may take us down a different path, that trying to do 2 presentations just wouldn't make a whole lot of sense. So as I said before, we really hope that we have opportunities in the future to come present to you. And I did definitely hear a couple of questions and comments. Hey, I see the technology over here. How's that going to work over there? I would say it's all sort of evolving at the moment, but you'll certainly see a lot of that sort of cross-pollination, as if you will, between our different product sets wherever we possibly can. I also want to sort of highlight there's other security technologies that are part of the greater HPE and even outside of our business unit that would also be great opportunities for us to come present on. Things like Zerto, for example, which focus a lot on ransomware prevention, detection, and so forth. So I think there's a lot that we can talk about. I want to thank you again very much for this, and we hope those of you watching enjoyed it as well. And of course, great conversations here, and I think we'll have a few more. So I think at this point, I'll go ahead and close out our session.